Hello guys, welcome to INSPIRE EDUCARE. I am Aditya. In this video, we will solve one problem from the topic 2D array, which is generally asked in interview. So today's question is that we are given a 2D array and we have to print that 2D array in a spiral form. So let's understand with the help of an example. Here we have an input of 2D array 4 cross 4 matrix. The elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the output comes out as this 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 5, 6, 7, 11, 10. This is the spiral form of this 2D array. So let's see how this spiral form comes out. So in this we have to print like this. First this row, then this. Then we have to print from this, then this, then this, then this, then this. That means we have to form a spiral in a clockwise direction. So now let's see how we can solve this question. So in this method we have to initialize 5 variables. The first is start row, initialize it with 0, end row, initialize it with n-1. So here we will consider n cross m 2D array. So start call is equal to 0, end call equal to m-1 and direction equal to 0. Here we have 4 direction. For this we will consider direction equal to 0. For this we will consider direction equal to 1. For this we will consider direction equal to 2, and for this we will consider direction equal to 3. So we will change our direction in each step. So let's see. When our direction is 0, dir equal to 0. So we have to print from start row, start column to end column. So here we have condition for I equal to start column. It will run up to less than equal to end column, and we will do I++, and we will print cout a of start row and I. So after completion of this row, we have to increase our start row. That means we have printed this row. Now the start row should point towards next row. So we will do start row plus plus, and we will change our direction to 1. So this is the code for direction equal to 0. So now let's see if direction will become equal to 1. So here we have to print like this. So means we have to start with the start row. So here start row will come and it will run till end row. So here comes end row, and in this we have a fixed end column and we have a variable of row. So here we have to print like this, a of I and end column. After completion of this row, we have to decrease our end column. That means we have printed the last column. Now we have to decrease our end column to this point. So we will do this end column minus minus, and now we will change our direction to 2. So now let's see for the direction equal to 2. So when the direction become equal to 2, we have an end column here and a start column here. So we have to traverse in this direction, end column to start column. So we will update our conditions here. So I will start from end column and it will run till start call, and we will do I minus minus. So in this, I is the variable and the fixed one is the end row. So here we will see out as a of end row. This is the fixed variable and here it is I. So after coming out of the loop, we have to increase our end row to this point. So we will do end row minus minus. Now we have to change our direction to equal to 3. So let's see for the direction 3 what we have to do. So we have to update our conditions here. So for direction 3, we have to start from end row and we have to go till start row in this direction. So I will start with end row and I will run till start row, and here we will update our I and I minus minus. Now we have to print these elements. So in this start column is fixed and we have a variable changing for row. So we will print a of I start call. Now after printing this column, we have to increase our start column to the next column. So we will do start call plus plus, and now we have to change our direction again to this. That means direction will update to 0. So we will run our loop till start row is less than equal to end row and end. Start call is less than equal to end call. So we will run our different if condition till this condition hold true. When this condition become false, it will comes out of the loop and the array will be printed in spiral form. So let's see the code for this. Starting with the main function, we have first declared two variables and an m. Then we have entered the number of row. Then we have entered number of column. We have created an array A. Then we have entered element by running the loop C in A I, j. Then we have printed the spiral print by calling the function spiral print, in which we have passed three argument. The first one is the 2D array, the second one is the number of row, the third one is the number of column. So let's see the spiral print function. So coming to the spiral print function, it had 5 variables declared in the starting. The first one is start row, which we have initialized with 0. The second one is end row, which is initialized with n-1. Third one is start call, which is initialized with 0. The fourth one is end underscore call, which is initialized with m-1. And there is a direction dir equal to 0 for the different direction in which we will traverse. So here is the condition for the loop till start underscore row is less than equal to end underscore row, and start underscore column is less than equal to end underscore call. So till then this loop will run and print the element according to the different direction. So coming to the first direction, if dir equal to 0, in this we will have to start traversing from start call till end call, and we have to print the element, and at last we have to increase our start row to point towards the next row, and we have to change our direction to 1. So in this we have done for int I equal to start underscore call, I less than equal to end underscore call, and I plus plus, and we have printed the element a start underscore row I, and we have increased our start row to point toward the next row, and we have changed our direction as 1. So when direction become equal to 1, in this we have to traverse from start underscore row to end underscore row. So we have done this by using this loop, and in this we have decreased our end call to point toward the next column, end call minus minus, and we will change our direction to 2. So we have updated dir equal to 2. So for dir equal to 2, that means we have to traverse in this direction. So here it will start from traversing from end underscore call to start underscore call. So we have run a loop in which I is initialized with end underscore call, and it will run till start underscore call. And we have printed the element a end underscore row I. Now we have to update our end row to point toward its previous row, which will now become the end row. So end row minus minus, and we will update our dir as 3. So for dir equal to 3, we have to traverse from end underscore row to start underscore row. So we have done this using this loop, and now we will update our start underscore call to point toward the next column. So we have done start underscore call plus plus, and now we will change our dir equal to 0. That means direction equal to 0. So this is the code part for this. The code is simple. So let's see the run part for this. Is this code working fine or not? So we have to enter number of rows. So let it be 4. Number of column, let it be 4. Enter element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now let's see the output. So here the output comes out as 1, 2, 3, 4. That means this 1, 2, 3, 4. Now we have to traverse like this. So the next output should be 8, 12, 16. So we have 8, 12, 16. Now we have to traverse like this. So the other element should be 15, 14, 13. So here come 15, 14, 13. Now we have to traverse in this direction. So the next output should be 9 and 5. So here come 9, 5. Now for this direction 6 and 7 should come. 6 and 7 had come. Now 11, and at last 10 should come. So here 11 and 10 had come. So the code is working fine. So that's all for this lecture. Thanks for watching. I will see you in next lecture. Till then, keep learning and keep exploring.